Today, I'll be presenting LiDAR360MLS efficient workflow, the seamless data processing to CAD imports. So firstly, I'll be going over the overview of LiDAR360MLS, SLAM, and Georeference processing. So I will do a very quick overview since this feature already exists since version 8. And I'm sure a lot of you who have used version 8 of MLS are already familiar with this. So I'll just be doing a very quick overview. So in the MLS version 8 SLAM updates, we have made it easier, better quality, more versatile, faster, more stable, and more intelligent. So to elaborate on those, it is 50% reduction in parameters for the SLAM processing. So there's no more hassle of having to configure each individual settings. 40% reduction in SLAM processing mode. So instead of many different modes, we have now condensed these modes so that they are more versatile and we don't have to stress about choosing the correct mode. Supports for closed loop manual editing, as well as streamlined optional interface. So it is faster. A new project can now be processed with one click and intelligent copying of image data. So instead of before, where you have to manually select each individual images project as well as data loaded into the program, you can instead use the one-click apply SLAM file to automatically add the entire project, and you can process the project with just one click. And it's also optimized the coloring algorithm, which allows for faster speed of colorization and new data set results directory with results folder and intermediate results stored separately. So instead of everything stored in one folder, it is now much clearer on which is the temporary data, which is the finished data, and which are the unprocessed raw data. As well as better quality, so clearer infrastructure of point cloud, as well as point cloud density increased by 4 to 6 times of realistic colorization. So here's, you can see the comparison between 7.2 and version 8. And here you can also see a comparison between the version 7 as well as version 8. And here is also another comparison of the point cloud thickness between version 7.2 and version 8. So it's also more stable, increases SLAM success rate to more than 90% through the algorithm optimization. By optimizing the feature extraction method for weak features, the success rate of weak features is improved. Time segmented point cloud with improved filtering and color assessment stability. And now it's also more versatile. Coordinate transformation parameters calculation, coordinate conversion, elevation system conversion, format conversion, data export, and more are all included in the toolbox, which was not there before. Supports various reports, accuracy report, PPK report, volume measurement report, as well as two-stage volume report. And also supports converting to MLS mapping project with just one click. So no need to import the project into MLS. You can click on the SLAM module to directly import into MLS. It's also more intelligent that it supports AI classification during SLAM processing, supports one-click moving objects for elimination. So this is kind of the difference, showcasing the difference between the MLS version 8 mobile versus the previous mobile processing, which we had to use Georeference. So it's more user-friendly, more efficient, more intelligent, and also more versatile. So to elaborate on some of these, so it supports drag and drop of the file directly into the processing module instead of having to load each individual project files like images or raw data files. More reasonable workflow and design, clearly visible batch task process, and new result data structure. is more efficient, allowing one-click conversion to MLS mapping project, realized batch processing of multi-project data, as well as parallel processing of point cloud and panoramic images. So there's also a new function of register, which allows easy handling of complex scenes. Also, the new function of trajectory jump repair, the software which allows the software to repair any jumps in trajectory. We'll showcase an example of that in a little bit. And the software also embeds a mask files for coloring point clouds, resulting in better data quality. It allows seamless loading of panoramic camera image data as well as planar image data. Supports deep learning classification of point cloud data based on AI in GV-Road module. The software can classify point cloud data into 11 categories. And also supports to generate various reports similar to LiDAR360, and now supports reports including trajectory plot, trajectory report, strip adjustment report, accuracy checked, and so on. So here's a couple examples of the data visualization. As I mentioned before, it supports trajectory jump. Supports removing this trajectory jump. So as you can see here, before there is a trajectory jump of elevation change, obviously is incorrect. After the trajectory jump repair, it now looks like a normal data set. It also supports an improved GCP adjustment with additionally, there's also the new strip adjustment feature. Here's the colorizing point cloud, supports panoramic or planar images, also supports mask files. You can colorize by time or distance, and supports depth map mode. Okay, so that was a quick overview of the SLAM as well as georeference processing in LiDAR360 MLS. So again, all of those shouldn't be any new information as those are released since version 8. So anyone that's already familiar with MLS version 8 should have used those features before, but that was just a quick refresher before we move on to part 2, which is road marking, vectorization, as well as CAD workflow introduction. So in the LiDAR360 MLS, the data extraction follows a process of first data processing, then marking extraction, then facility extraction, vector editor, attribute editor, symbolization, and lastly, quality control. So I'll go over each of these in order before we move on to the CAD processing. So in the data processing, there are many different options. For example, there is a road scene extraction, which you can extract, register, export as classified, as well as conduct production, as well as transformation. So here in the toolbox, you can simply search for what you need. In this case, let's say if you want to do road scene extraction, you can search that and then click on the tool directly. So in the toolbox, there is a favorite section which you frequently use, or you can set as favorite. There are 60 plus point cloud tools, there are 100 plus vector tools, and there's 20 plus raster tools. So for example, you can cut the data set into multiple blocks to improve efficiency. So you can run the data set one block at a time instead of having to run the whole data set at the same time. So marking extraction. So as you can see, there are many different ways to extract a marking. For example, you can do automated lane extraction. You can do symbol drawing. You can do automatic drawing of arrow symbols. There's also crosswalk template drawing, alphabetic symbol drawing, automatic lane dash detection. So it just depends on your use case as well as your road conditions and what markings you're trying to extract. So here we have a customized road marking extraction model trained based on synthetic samples. So if a rich sample library is provided, then the software can learn from that sample and in turn be able to extract intelligently the scenes automatically without much human interaction. And what's new in version 8 is that we now included North American road marking extraction models, which is built-in automatic extraction models and symbol library for North American road and markings. So the facility extraction, which is similar to road sign extraction, there's many different steps as well. There's many different steps and ways to extract different features as well as facilities of the road. So again, there is linear facility automatic extraction. There's batch extraction of poles, light poles or telephone poles, power line batch extraction, automated roadside detection, traffic sign without penetration drawing, automatic detection of rails and center lines. And it supports street trees, pole buildings, vehicles, seed point based individual segmentation, supports object editing, and supports individual object parameter calculation and editing. So once we have the markings as well as facility extracted, you can move on to vector editor. So the vector mapping with multi-source data fusion allows 3D mapping based on point clouds, 3D mapping based on imagery, 2D horizontal and vertical section mapping, over 100 vector mapping processes, as well as editing tools. Supports for line, lane, polygon, multi-point, multi-lane, or multi-polygon. Support vector mode, snapping, and editing modes. Vector layer and attribute management, field calculation and sorting. Built-in tool library appearance and annotations, and multiple output formats, seamlessly integration with GIS, CAD, and simulation platforms. So here are some of the examples of vectorization of roads. As you can see here, you could extend, trim, lane split objects, trace, fillet, adjust, reshape, smooth, and line to polygon. And here are some image-based vector drawing and editing. So as you can see here, it's using the colorized point cloud as well as photogrammetry to help with the vectorization. And we also have the node editor in case any of the automated extraction is incorrect or incomplete. You can use the node editor to manually edit and fix some of the errors. And then we have the attribute editor, which supports template configuration, as well as field calculator and sorting. So the field calculator includes over 300 built-in functions and provides a Python scripting tool. And the object photo database storage stores a quick photo capture and allows for batch export. And then we have symbolization, which is a built-in road asset symbol library and general symbol library built for displaying attribute fields by labels, supports for adding and modifying annotations, and supports for attribute labels and annotations. And lastly, we have some of the quality control tools. So for example, in our attribute quality check tool, we can perform reliability check, validity check, empty value check, as well as custom value check. And we also have some geometric quality check tools. So once you ensure that the quality is sufficient, you can export into various CAD supported formats, such as CPKG, KML, JSON, SHP, as well as many other formats. And once you have the exported CAD supported formats dataset, you can then go to the auto tag feature. Under your LiDAR360MLS tab, you can click import database and then select the format of the dataset and then import the dataset directly into the AutoCAD feature, into the AutoCAD software. And before I start with the software, with the showcase feature, in case you're wondering how we have the LiDAR360 into the AutoCAD software, I will go over that in just a moment. But first, we will look at some project showcases. So this project showcase is generously provided from our friend Dprom from Thailand. So any of the data set as well as any photos and features are from them. So again, thank you for Dprom for supplying us these photos as well as data set for us to present this case study. So in this case, the data set was acquired using the DGC50 Light Backpack device, and the data set is processed in LiDAR360 MLS, the Light Geo module, and the road marking and vectorization is done in MLS. And lastly, the symbology is done with the MLS CAD plugin in the AutoCAD software. So here, the Light Backpack, just to give a general overview, has two sensors, one horizontal, one slanted, and has a scan range of 120 meters, a scan rate of 640,000 points per second, a relative accuracy of 3 centimeters, and an absolute accuracy of 5 centimeters. So here, our client used the data processing with one click. So they were able to use a LiSLAM file, as mentioned before, and directly import it into the software. And with that, they were able to process data with one click without having to import any other imagery data or any other files. After which, they completed the road marking vectorization. So they used which has a hybrid workflow, so semi-automatic workflow, which accelerates vectorization of roads, arrows, sidewalks with AI assisted detection. There's also manual tools which were used, such as fine-tuned results, which will allow you to fine-tune the results with 50 plus vector editing tools. They also use the AI powered detection as well as customization using pre-trained AI models, as well as training their own AI models to better enhance the AI classification. Lastly, the use of vectorization module for smart editing, for geometric correction, layer management, and topology validation. And lastly, they exported the file into a CAD supported format. And here's a showcase of the data set. Okay. And here are some of the top-down views of the project from the AutoCAD software. Okay, so now I will go over the AutoCAD plugin. So to install the AutoCAD plugin for MLS, for LiDAR360 MLS is very simple. Simply open the LiDAR360 MLS software. And in the search box or in the toolbox, search install LiDAR360 MLS plugin for AutoCAD, or you can simply just search AutoCAD and this option should pop up. And once you click on this option, it will prompt you to select the AutoCAD versions that you have installed. Currently, the software supports AutoCAD versions 2022, 2023, as well as 2024. So if you select one of these versions, you can click OK to install the LiDAR360 MLS plugin onto the AutoCAD software. So once you install that plugin, when you open the AutoCAD software, you will see this extra tab called LiDAR360 MLS, where you can import LiDAR360 MLS datasets. So as mentioned before, it supports the import of GPKG, SHP, XDF, SHV, JSON, GeoJSON, tables, and rasters, and supports the export of all of the above file formats as well. And supports attribute queries, seamlessly integration of geometric attributes, annotation styles with CAD. So here are some of the feature highlights. So the first one we'll highlight is the define style function. You can select the symbol you wish to customize and press the enter key, set the symbol name, and save it as a symbol. Proceed in this manner until all symbols has been defined. And then from there, you can manage the style, or you can view the defined styles and perform options such as renaming, deleting, importing, and exporting styles. Here's a quick video showcasing that toolset of define style as well as edit styles. So here, as you can see, we define all the styles that we selected. Okay, so now we're moving on to edit point styles. So in this feature, you can interactively select multiple points features and edit their styles. So select the point style that needs to be changed, click interactive edit point styles and select specific point style and click OK to complete the replacement of the corresponding point style. You can also edit point style by layer. So edit point style corresponding to the field value by selecting the layer and filtering the field. Click point styles by layer, select the corresponding layer to the field to be filtered, and click OK to refresh the styles of point features in the badge. You can filter by a single field or multiple fields. You can select up to 3 fields for joint filtering. So here's a video showcasing the edit point styles. So as you can see, where we created many different points, and we can simply select those and change them into the desired attribute. In this case, the points were changed into trees. So now we'll go over edit line style. So edit the line style color and width by interactively selecting single or multiple line features. Select the line whose symbol needs to be changed. Click interactively edit line styles function. Set the line type, color, and width, then click OK. And here is showcasing the edit line style by layer function, which you can select the layer and the field to be filtered, then select the line color, type, and width at the corresponding field value, and then click OK. So here's a quick showcase of the line editing feature. As you can see, first we're selecting the lines. We can adjust the line in here by layer. So we can change the color of the line, change the width of the line, as well as the style of the line. Okay, so next we will go over annotation style. So we can edit annotation style interactively, select an annotation whose symbol needs to be changed. Click the edit annotation interactively function, set the font color, size, and angle, then click OK. The font size can have up to 4 decimal places. The font color, size, and angle parameters of the annotation can be modified individually or in combination. And you can also edit the annotation by layer. Click the edit annotation by layer function, select the layer and the field to be filtered, set the font color, size, and angle in the corresponding field volume, and then click OK. And here's a quick video showcasing that. We can also change the entity color by clicking on the edit style by unique values function. Select the layer, filter the field, modify the color at the corresponding field, then click OK. You can filter by a single field or multiple fields, and up to 3 fields can be used for joint filtering. There's also auxiliary functions. So for example, you can view the attribute fields and attribute values of the elements in the current window. And you can click the restore to zoom to the full range of data in the view. So if you zoomed in too much and is unable to determine where you are in the dataset, you can restore and zoom out. And there's also, of course, the about section as well as the help, which you can click on to open up the user manual for the LiDAR360MLS for AutoCAD plugin. And lastly, you can always go on our YouTube channel, which has multiple CAD plugin tutorials. So simply go to our YouTube channel, and then within our YouTube channel, search up CAD, and you can see all the other listed CAD plugin tutorials. And that is all for this webinar. Thank you so much for attending. And now we are open to questions. So I have a question asking, transformation using equation option is available. I'm not exactly sure what that is referring to. If possible, can you provide more information in another comment? Okay, I see the question's already been answered. So sorry about that. Let me see if there's any questions that hasn't been answered. So what is the success rate for MLS to discover all lane markings successfully? Is there any measure? So currently would say we have a success rate of 90% or greater under ideal conditions. So if the data set is ideal and there's no interference, then it should be 9% or above. But obviously, if the data set is a little bit blurry, or if the data set have a lots of errors, or it's a uncommon type of road, then the success rate might be a little bit lower. But under ideal conditions, we stand behind 90% success rate. Are there any capabilities for extracting things other than roads, such as pipes in a facility? So as for LiDAR360 MLS, for pipes in a facility, I don't think so. But we do have that feature in the regular LiDAR360, not in the MLS module, because the MLS module is more geared towards the roadside as well as any road related facilities. However, if you're looking at just inside a facility with power or with pipes, then I would recommend checking out LiDAR360, not the LiDAR360 MLS. And we have a question asking, can we extract power line? Yes, you can absolutely extract roadside power lines. So yes, the question is, if lane markings are not visible due to erosion, then what is the recommended fix for such case? in such cases, if there's erosion and the software cannot pick up the eroded signs, or if the erosion completely removed any markings on the floor, then in that case, you will have to manually edit. So the software is intelligent enough where if there's tiny gaps, it will be able to jump over those gaps and continue the vectorization of the road signs or of the road lanes. But if if the erosion is too much and the gap is too great, then unfortunately there will be a gap and manual editing is required to basically close that gap. So another question is, can we extract a transmission tower? So technically, yes. However, those are usually very high as well as mm, very high as well as very long. So I'm not exactly sure if the data set will be complete enough for it to be extracted. So for example, if you were to use a handheld or backpack mapper, it might not be able to see all the lines, especially on top. So it might be a little bit difficult. However, if the data set is able to show clearly all the power lines as well as all the structures, then it shouldn't have a problem with extracting transmission power lines. Can I apply tracing paint marks in indoor parking lot? Tracing paint marks in indoor. I'm not exactly sure what you're asking, but I'm assuming that you're asking if it can pick up the parking lot lines in an indoor parking lot, then in that case it should be because the lines should have a different intensity compared to the ground, and that's how the software is able to pick it up. So as long as you're able to see it in the LiDAR data set, then the software should be able to pick it up. How small can the trained objects be, or does it depend on point density? That's a very good question. I would assume it should. Mm, Sarah, can you help answer this question? And hopefully that answers your question, Javier. If not, please let me know, and we can maybe take a look at your data and see like what can be done. But that's kind of the general consensus that we came up with based on your question. Okay, with that being said, if we have any more last minute questions, please let us know. We will end this webinar by 8 p.m. Pacific time. And if there's no other questions, then I would like to thank everyone for participating. And hopefully we'll get to see you guys again in the next webinar.